Hey everyone, and welcome. Get ready, because we're about to jump into something really cool today. We're talking about neuromorphic computing.
Yeah, it's basically computers, but like inspired by the way our brains work.
Exactly. And we've got a ton of research and articles here, a whole stack of them. So basically,
Oh yeah, we're going deep.
we're going to figure out just how this brain-inspired tech actually works, plus what it can do, the potential.
The potential.
And of course, what kind of challenges are ahead for it.
And one of the really cool things about neuromorphic computing is it's event-driven.
Event-driven. Okay, so what's that mean?
Well, think about it like this. Our brains, right, they react to stuff in real time. It's not like there's a little clock in there, tick-tock, tick-tock.
Like it's all instant.
It's instant. And these neuromorphic systems, they're the same way. They process information based on what's happening around them.
Interesting. So instead of waiting for a signal, it's just reacting to changes. Makes sense.
Exactly.
Yeah.
And that actually saves a ton of energy.
Oh, I bet. Especially with how much power computers use these days, that's going to be a big plus.
Huge advantage, yeah. Especially as our energy demands just keep growing.
Makes sense. Okay, so then there's this whole idea of parallelism. I saw that in a bunch of the articles. What's that all about?
So picture your brain. Billions of neurons all doing their thing at the same time.
A lot going on up there.
A lot going on. And neuromorphic computing, it's trying to copy that. So you have loads of processing units all working together, just like those neural networks in our brains. And that means they can tackle really complicated problems super fast.
Okay, now I'm starting to see why people are so excited about this. It's like a whole new level of computing power, right?
It really is.
Yeah.
And then there's this super fascinating thing called synaptic plasticity.
Okay, synaptic plasticity. Now that sounds complicated.
Well, it's basically the brain's way of learning. You know, how connections between neurons get stronger based on our experiences.
Ah, so it's like the more you use it, the better it gets.
Kind of. So in these neuromorphic systems, the more they experience, the more they learn and change how they respond.
Okay, so they actually learn and adapt over time. That's kind of wild, isn't it?
It is pretty mind-blowing. Imagine, having systems that just constantly improve, solving problems we haven't even thought of yet.
That's a pretty revolutionary concept.
Definitely. And speaking of revolutionary, we should probably mention Carver Mead.
Carver Mead.
Yeah, he was the one who came up with the term neuromorphic way back in the late 80s.
Wow, the late 80s. He was way ahead of the game.
Definitely a visionary. And, since then, we've seen some really incredible hardware come out. Like, there's this article about IBM's TrueNorth chip.
Yeah, I read about that one. Sounds like something straight out of science fiction.
Kinda is. It's a single chip with over 1 million neurons and 256 million synapses.
On one chip?
That's nuts. Yeah, and the craziest part, it only uses 70 milliwatts of power.
Seriously? That's less than a light bulb.
Yep.
And it's got the processing power of, 1 million neurons.
It's pretty remarkable. A real engineering feat.
Shows you just how far we've come with bringing those brain principles to, actual silicon.
Yeah, absolutely. And TrueNorth isn't the only one out there.
Right. There's another article about something called Spinnaker. I think it was a project at the University of Manchester.
Oh, yeah. Spinnaker's really cool. It's a massive system designed to simulate brains, but in real time.
In real time, wow.
Yeah, and it can actually simulate up to 1 billion neurons all at once.
1 billion neurons. Isn't that like getting close to some actual animal brains?
It really is. Gives researchers a whole new way to study how the brain works.
Fascinating. Then there's this one, BrainScaleS, right? I think it was at Heidelberg University, something about a supercomputer.
Oh yeah, BrainScaleS is crazy fast.
Yeah.
It runs 864 times faster than real biological neurons. Like, imagine squeezing a whole day of brain activity into less than 2 minutes.
Whoa, speeding things up like that, that's got to be super useful for research, right?
Oh, absolutely. They can run experiments and test algorithms so much faster.
It's amazing that we can not only mimic the brain, but also kind of mess with its speed like that.
It really shows you the potential of this whole field. We're not just replicating, we're exploring totally new possibilities with it.
I like that. Okay, so we've got all this amazing hardware, but what about the software side? How do you even program something that acts like a brain?
That is one of the biggest challenges right now. You can't just take our old programming methods and apply them to this. It just doesn't work.
Right. It's a whole different way of thinking.
It is. Some people are trying to adapt the deep learning models we already have, but others are going in totally different directions.
Like what?
Oh, all sorts of stuff. Evolutionary algorithms, even graph theory. It's really cutting-edge stuff.
Sounds like a whole new world for computer science.
Definitely. And we're just starting to figure it all out. It's a fast-moving field, lots of potential, lots of challenges too.
But hey, we've come a long way in just a few years, right?
Absolutely. It's pretty remarkable, the progress that's been made.
So we've talked a lot about the tech side, all this amazing hardware and software. But I'm curious, what does it actually mean for like the everyday person? Why should anyone care about this neuromorphic computing stuff?
Yeah, that's the big question, right? Easy to get caught up in the details, but like at the end of the day, this could really change things for all of us.
Oh, really change things. Oh, okay. So like, give me the big picture here.
Imagine your smartphone, but it's not just smart. It's actually intelligent, like really intelligent. Learns your habits, knows what you need before you even do, solves problems you haven't even run into yet. And it does all that without killing your battery.
Okay, that sounds pretty amazing.
Right. And it all comes back to that adaptability we were talking about earlier. Remember how these systems can learn and evolve.
Ah, right, right. So it's not just about being powerful. It's about being able to change, adapt to new situations.
Exactly. And that's huge for things like, self-driving cars. Got to be able to handle crazy traffic, make decisions on the fly.
Yeah, you can't program a car for every possible scenario, right? It needs to learn and adapt.
Exactly.
Yeah.
Or think about robots working with people. Environments are always changing. They got to be able to keep up.
Makes sense. Oh, and what about the energy efficiency part? We were talking about that earlier.
Oh, huge deal. Especially nowadays. Everyone's worried about saving energy, right?
Definitely, especially with all these devices and the Internet of Things. Everyone wants to be connected all the time.
And that takes power. But with neuromorphic computing, we could do all these complex calculations, but using way less energy.
Okay, that's a big win for sure.
Yeah, smartphones, wearables, even giant data centers, it's a game changer for all of them.
So we've got the adaptability, the efficiency, and of course we can't forget about the sheer power of these brain-inspired chips, right?
Oh yeah, they're built for speed and efficiency.
Yeah.
Processing tons of data all at once, no problem.
That's that parallel processing thing, right?
Yep. And that means they're perfect for stuff that needs instant responses. Sensory processing, robotics, even financial modeling.
Okay, so we're talking about a technology that could basically touch every part of our lives.
It really could.
Yeah.
Healthcare, manufacturing, research, you name it, the applications are pretty much endless.
It's exciting, but kind of overwhelming too. So much potential. But I guess it's not all easy, right? What are some of the challenges with this stuff?
Oh yeah, definitely. Scaling things up, that's a big one. We made a lot of progress, but building something as complex as the human brain, that's a huge undertaking.
Well, yeah, we're talking about billions of neurons, all connected in super intricate ways.
Exactly. And just replicating that on a large scale, that's a major hurdle.
And it's not just the number of neurons, right? It's also how they're all wired together, how they talk to each other.
It's like, imagine trying to reverse engineer the internet, but for the brain. Super complicated stuff.
So we've got the hardware, we're getting better with the software, but there's still a lot to figure out.
There is. And then there's this whole issue of how we program these things. Like we were saying earlier, the old ways just don't work.
Right. Need a whole new approach.
Exactly. Another challenge is, how do we actually integrate this with all the tech we already have?
Yeah, it's like having this super fast car, but no roads to drive it on.
Exactly.
Yeah.
We've got to build those connections, make this new tech work with the digital world we live in.
Okay, so we've got the scaling problem, the programming problem, the integration problem. Anything else?
Well, accuracy is a big one. Got to make sure these systems are at least as good as the traditional methods, especially for things like healthcare, finance, stuff that really matters.
Yeah, I can't be messing around with people's health or money if the tech's not reliable.
Exactly. But researchers are working on it, and we're seeing improvements all the time.
That's good to hear. Okay, so all these challenges aside, I'm really curious about specific applications. Where might we actually see neuromorphic computing being used soon?
That's the fun part. Think about your senses, like sight, sound, touch. This tech could completely change how computers handle that stuff.
So like better computer vision, speech recognition that actually sounds natural, robots that can actually feel things properly.
Exactly. Imagine robots in factories that can learn from their surroundings, work alongside people in a much more intuitive way.
Oh, that's cool. What about healthcare? I feel like there are a ton of possibilities there.
Oh, for sure. Imagine wearables that actually predict health problems before they even happen, or prosthetic limbs that feel and move more naturally.
Wow, that's next level stuff. Talk
Yeah.
about personalized healthcare.
Right. What about cybersecurity? I bet that's a good one too.
Oh, yeah, for sure. Got to be able to keep up with all the hackers and stuff.
Exactly. These neuromorphic systems, they could spot threats in real time, just like our brains do, picking up on patterns and stuff.
Makes sense. They'd be like our super-powered security guards watching out for anything suspicious.
Exactly. And we haven't even talked about the possibilities for scientific research, simulating complex stuff, like climate change or even the brain itself.
So, by studying artificial brains, we can learn even more about our own brains. That's pretty tricky.
It is, and it just goes to show we're really just scratching the surface with this tech. So much more to discover.
It's mind-blowing for sure, all these potential applications, but I guess, with any powerful technology, we got to be careful, right? Think about the impact it could have on society.
Oh, absolutely. We need to have those conversations, the ethical considerations, make sure it's developed and used responsibly.
Well, I think we've given everyone a lot to think about today. From the science to the possibilities, it's been quite a deep dive.
It has. Neuromorphic computing, it's definitely a technology to watch, that's for sure.
So, to all our listeners out there, stay curious, do some more research. Who knows, the future of computing might be closer than you think.
And, hey, maybe one of you listening will be the one to make the next big breakthrough.
Until next time, keep exploring, keep learning. It feels like we're really at the edge of a whole new era for computers, not just tools anymore, but like actual partners helping us solve problems and make discoveries.
Yeah, and it's exciting to be a part of it,
Yeah,
The advancements in hardware and software have been amazing, and the possibilities, they're just, wow, they're endless.
totally. We've talked about self-driving cars, intelligent robots, healthcare that's personalized, even cybersecurity that can keep up with the bad guys.
Yeah.
It's a lot to take in, but it seems like neuromorphic computing could really change everything.
Absolutely. But I think it's important to remember we're still in the early stages. We've got a lot to learn, a lot to figure out.
Yeah, it's like we've just opened this door to a whole new world, and we're just starting to peek inside. But we got to be careful too, right? We're talking about some powerful stuff here.
Right. Any technology this powerful, there's going to be risks, challenges. We need to be thoughtful about how we develop it, how we use it.
Well, I think we've given everyone a lot to think about today. All the science behind it, the potential it has. It's been quite a journey.
It really has. And one thing's for sure, neuromorphic computing, it's definitely a field to keep your eye on.
So to all our listeners out there, stay curious, do your own research, explore this stuff. Who knows, maybe the future of computing is closer than you think.
And maybe, just maybe, one of you listening right now will be the one to make that next big discovery.
Until next time, keep exploring and keep learning.